Okay, I want to walk you through a little bit of the lab. This is lab 11.2 and some important parts here. So at this point, you should have completed lab 11.1 where you're testing the basic and OR gates. The circuit is a little bit more complicated. Please take the time to read through my notes here. These come from many years of burning up parts and having problems and having difficulty with labs. So I'm trying to give you as many tips as I've learned. So please read through these. But let's take a look at the circuit, and I'm going to go over breadboarding it. Okay, so step one, you want to collect all the parts. Make sure you can identify them, the push button switches, the logic gate, integrated circuits, resistors, LED, and 330 ohm resistor. When I'm breadboarding these types of circuits, I like to leave lots of space and not try to squeeze everything into a corner. And I'm going to start with the logic gates. I'm going to put them up kind of towards the top. Make sure when you plug them in that they straddle the center area. They're not going over too far. And then I'm going to connect the power pins to the corner, pin 7 and 14. Okay, so I've got the power pins connected there. Should have mentioned also that we want to make sure that the power is disconnected before we wire that up. So once I've made those connections, I'm just going to cross off the connections. You could use a highlighter, colored pen, whatever you want, just to make sure you know what you've connected already in the circuit. Since there are a lot of wires here, you want to keep track of that. Since we got lots of room here, I'm going to move these switches down to the next area here. And the inputs here you can see are connected to 5 volts. So I'm going to wire that to 5 volts on that side. Move this switch down a little bit. And again, always make sure your switches are lined up like side to side like that, so the pins are left to right. And then the other sides go through a 1K resistor to ground. So I got those connections done there, there, and there. And we need to connect the 1K resistors. And the way I'm going to do this is kind of stretch all the way to the ground here. So that's going to the ground there. It could go on the top one also, but I'm just trying to leave as much space as I can. And the ground connection there like that. Now, this is important. If you're going to do it this way, you've got to make sure that all your red and black bus strips are connected together. Otherwise, it won't work. And then the next thing to do is we're going to connect. So we got those connected to ground and to the switch there. And the next thing we're going to do is run 2 jumpers to pins 1 and 2 on the 7432. So I'm going to use this one here. Go to pin 1. And this one here. I'm going to go to pin 2. And I'll probably zoom in on this a little bit closer in a little bit. But you can see how that's connected there. So those 2 connections are made. So those are all the inputs. Now let's go ahead and finish up the 3rd switch, which is going to the 7408. So I'm going to take the input of the switch, go to 5 volts, which is on the red bus there, and the output is going to go to pin 4. So counting left to right, 1, 2, 3, 4. And we also have a 1K resistor that, slide this up a little bit. There we go. And another 1K resistor that's going to pull that down. The reason we need those resistors there is that because the input currents are so small on these logic gates that if the switch is not pressed and the switch, it was just floating, if it wasn't closed and there wasn't a resistor there, that wire wouldn't be connected to anything, and you could literally touch the wire and it would turn it on and off. So we made that connection, that connection, that connection, and 4. And now we're going to connect the output pin, pin 6. And easy way to do that, let me zoom in a little bit here, is we're going to simply connect, whoops, I missed something, didn't I? Oh, hopefully you were watching that. We also need to connect pin 3 on the OR gate to pin 5 here. So pin 3 to pin 5, like that. And then the output we're going to connect to a resistor. I'm just going to plug the resistor right in there. That's a 330 ohm. And then we're going to connect the LED. So that takes care of that connection there and there. And now the 330 ohm resistor is going to go to the LED to ground. And remember, with LEDs, of course, we want to make sure that the longer lead, the positive lead, is going to the positive side, and ground is going there, like that. I will use the blue LED. Make it look a little fancy. Okay. So what I do at this point then is I go through and double check the circuit. Make sure everything is wired up. It saves so much time if you take the time to check it twice before you power it up. Make sure all the power leads are connected and everything's ready. So we'll power it up and see what happens. Okay, so let's see what we expect will happen. We have an OR gate here, so that if either of these buttons are pressed, it would put a 1 on either of these inputs going into the AND gate. But the AND gate will only put out an output, a 1 or 5 volts in this case, if switch 3 is also pressed. So let's try that. I'm going to press switch 3, and I'm going to press either of the other buttons. No, not working. Let's see if we can figure out what's going on here. Double check the LED. It's wired properly. I'm going to quickly check the LED to make sure it's working by connecting the resistor to 5 volts. And the LED is not working. So let me replace it with another LED. There we go. Okay, so I had a bad LED. Let's go ahead and connect back to pin 6 and try the circuit again. So in this case, I'm going to press the inputs to the OR gate. Nothing happens. I'm going to press the input here to the AND gate. Nothing happens. But if I press this switch 3 and then press either of these, the LED should come on. Okay, so this is kind of a lockout circuit where if you've got two inputs coming in but they cannot be allowed unless the AND gate is wired up or that input is enabled, it won't allow those signals to go through. So that's an example of how to wire up that lab. Go ahead and continue on the next parts. Actually, I'm going to go through the 555 wiring real quick too, but this gives you an example. So keep watching, please. So for the last lab, we're using this 555 timer chip. This is actually a pretty old device. It's been around for many years, but very cool part. We'll talk about it in a couple of weeks. Couple things that are important. Pin 1 is in the bottom left corner. The way I can tell that, there's a little dot there, but also the way the text is printed, it's pretty easy to see that that's the way it should be oriented. So pins again, 1, 2, 3, 4, 5, 6, 7, and 8 going in a circle. But you'll notice on the schematic that it does not follow that same convention. In other words, if you look at the package, it doesn't seem to relate to this at all. You might think, why do they do that? Why wouldn't they draw the circuit the way it's drawn out or laid out on the part? The reason why is that these pins, 7, 6, and 2, are input pins. Power is on the top, 5 volts, and ground is on the bottom, and the output is on the right. So for a lot of logic circuits, they will always use this convention. Inputs on the left, outputs on the right, power and ground on the top and the bottom. So let's go ahead and wire this up. Again, I will wire the power pins first, but you got to make sure you turn the power off before you start. Okay, so I've wired my power pins there. Ground is pin 1, and then 4 and 8 go to 5 volts. I try to use a little bit of color coding. Black is usually used for ground, red for the positive leads here. And now I'm going to connect, let's see, we'll do C1 first. Now in this lab I list a 22 microfarad, but you can use a 10 microfarad. Some of your kits may be a little bit different. And you'll notice it goes between pins 1 and 2, or I could go from ground to pin 2. So again, with capacitors like LEDs, the longer lead is positive, the shorter lead is negative. So I'm going to bend this and plug in pin 1, positive, to there, and then the negative side of the capacitor is going to go to ground. So hopefully you can see how that's wired up. So that's the capacitor. Pins 2 and 6 are connected together. So I'm going to run a wire from pin 2. And remember again, it goes 1 through 4, 5, 6. Over on this side goes around. 10K resistor now between pins 6 and 7. Oops, got to find that. Okay, so here's a 10K resistor, brown, black, orange. I'm going to show you a little trick with this, and I don't mind you doing this on your resistors in your kit because I replace them usually each semester. But if you bend the leads like that and clip them, maybe, I don't know, 1/4 of an inch between them like that, you can do it. There we go. We can now plug that directly in between pins 6 and 7. That's going to go all the way up here between pins 6 and 7. So that's kind of a convenient way to wire up that resistor. So you got that resistor going to 7. And then we got one more resistor going from 7 to 8. We can do the same thing. But in this case, I want to play around with this value a little bit. So I'm just going to bend the leads like that and plug it in. Okay. And then the output, what we're going to do to test this is just to connect it to an LED through a 330 ohm resistor. So I plugged that 330 ohm into pin 3, and then I'm going to connect to the LED and go to ground, just like the output of a logic gate circuit. So let's hook this up and see what happens. Okay, and I had pin 1, the capacitor was slid over one position there. So basically what I'm doing here is adding a resistor and an LED going to ground like that to test it. And you can see it's flashing there. And if you want to just play around with some of those values, you can. Changing the values changes the duty cycle. We'll talk about that later on, how long it's on compared to the whole period of the signal. And we can change the flash rate. For example, if we put another capacitor in parallel with this capacitor increases as you increase the value of the capacitance, and now the flash rate slows down quite a bit. So if you want to play around with those values a little bit, that's fine, but that's the basic circuit. Now, for the next lab, for that last lab, this is very important. What you're going to do is that where it says 555 circuit, that is the circuit that I just built right there. So that's kind of like that box shown in this whole circuit here. So you want to wire that up before you do the rest. Okay, so hopefully that'll help you get through these labs. If you have any questions, feel free to drop in for office hours or send me an email. I'm happy to go over anything at any point.